So now Simpsons Rule. Simpsons Rule, this is a BC only topic. This is a method of estimating a definite integral that does not use rectangles. It does not use trapezoids. It uses what are semi-paraboloids. What it basically is think upside down half parabolas. This gives us really, really good estimates with very few shapes. So 4 rectangles did not give us very good estimates. 4 trapezoids, not a great estimate. It's better than the rectangles, but still not perfect. But Simpsons Rule, we can get nearly exact estimates for very few semi-paraboloids, especially if we're doing this uh, with polynomials. Like with polynomials, I could do it typically four partitions, and I can get an exact estimate. Drawbacks. We have to have an even number of intervals so that we end up with a whole number of paraboloids, instead of just like 2.5 paraboloids. And it takes a while. This one takes the most time, and I will admit it's hard for me to remember all of the different coefficients I have to use. And this is because centuries ago, somebody figured out a formula for area of a parabola, or paraboloid, since we're cutting it in half and using half of the parabola. And so to do this, if I want to estimate the integral from a to b of a function, I take b minus a, the width of the region, divided by 3 times the number of intervals. So if I'm using 4, n is 4. Then I take the y value at a plus 4 times the y value at the first x, at the end of that first interval, plus 2 times the next y, plus 4 times the next y, plus 2 times the next one, plus 4 times the next one, plus 2 times the next one, plus 4 times the next one, all the way up until I get to the last y, which is just going to have a coefficient of 1. And you're seeing now why this is just going to take a while. So if I want to use the Simpsons rule with 4 subintervals to approximate the integral from 1 to 3 of x cubed, well, here's the graph of, whoops, I can do better than that if it would let me erase. Of x cubed. I'm going from 1 to 3, which means if I'm doing 4 subintervals, 1.5 to 2, and 2 to 2.5. So I need to do b minus a, so 3 minus 1, over 3 times the number of intervals, which they tell me is 4. So I have 3 minus 1 over 3 times 4. I need to plug the 1 in first, so that's 1 cubed, plus 4 times my next x, which is 1.5 cubed, because I'm just plugging that into the x cubed function, plus 2 times the next x, 2 cubed, plus 4 times the next x, 2.5 cubed, and the next one is my final x, so I'm just plugging that in with a coefficient of 1. And when I simplify this, I get 20, which, if I actually evaluate this integral, it's 20. So this not only estimated, this actually found it perfectly for me. That's how good Simpsons rule is at giving estimates. It just takes a lot of effort to find this estimate. This is typically 1, maybe 2 multiple choice problems in the entire AP exam. They do not ask a lot of these.